All right, so get this. We're diving into, like, billions of years of Earth's history today.
Wow.
Yeah, no, seriously. But the cool part is we're seeing it all through this awesome Vietnamese video series. I had no idea Earth's story could be so, well, exciting.
It's easy to get bogged down with the dates and the jargon when you're talking about deep time, but when you really think about it, we're talking about the entire history of, well, everything. Life, continents, the air we breathe. It all happened on this stage on Earth over billions of years. And understanding that story, it's not just about the past, it's about understanding our place in the universe right now.
Exactly. And you know what I love about this video series? It doesn't hold back on the weird stuff. We're talking seriously strange creatures and wild events that would completely change the planet. It really makes you appreciate how much Earth has been through.
It really shows how dynamic Earth is. I mean, just take the very beginning, the Hadean Eon, for example.
Oh yeah, the Hadean, even the name sounds intense.
Yeah, and for good reason. The Hadean, it's named after Hades, the underworld, and it really fits. Imagine a molten hellscape, constantly bombarded by asteroids. Not exactly a vacation spot.
No kidding, you definitely need some serious sunscreen. But even in that chaos, something incredible was happening, right?
You're right. That's when the building blocks of life started coming together.
It's mind-boggling to think about those first life forms way back in the Archean Eon.
We're talking about 3.5 billion years ago.
3.5 billion.
These were single-celled organisms, tiny, but they were the pioneers of life on Earth, emerging in conditions that would be completely hostile to us today.
Makes you wonder what we might find at other planets.
Ah, right. It certainly does. And these early microbes, they weren't just sitting around. They actually completely transformed the planet.
Oh yeah, I remember this part. It all comes down to oxygen, or rather the lack of it.
Right. So one group of these microbes, cyanobacteria, they figured out this whole photosynthesis thing.
And just like that, the planet had oxygen.
Well, not quite that fast. But over time, they pumped enough oxygen into the atmosphere to trigger what we call the Great Oxidation Event.
Which sounds impressive, and it was. But it's crazy to think about how oxygen, which we need to survive, was actually toxic to most life back then.
That's right.
It's like Earth pulled the rug out from under its own inhabitants.
You could say that, but it's actually a perfect example of how something seemingly devastating in the short term can be crucial for long-term change. And without the Great Oxidation Event, we wouldn't have the diversity of life we see today.
So true. But the story doesn't end there.
Right.
We're talking billions of years, remember?
Billions, and things get really interesting as we move into the Proterozoic Eon.
This is when things start to get a bit bigger, right?
Exactly.
No more just single-celled organisms. We're talking multicellular life, and this is where we find the Ediacaran biota. Now, I have to admit, I'd never heard of these guys before watching this series. What are they exactly?
Well, that's the mystery, isn't it? The Ediacaran biota, they're these enigmatic life forms that existed before the Cambrian Explosion.
So we're talking really old.
We're talking some of the earliest complex life on Earth. And honestly, we're still trying to figure out what most of them were.
So they're kind of like the weird, distant relatives that nobody really talks about.
That's one way to put it. There's Dickinsonia, for example. It looks like a giant quilted bath mat. Nobody knows quite where it fits in the tree of life.
That's wild.
Yeah.
It really goes to show how much we still don't know about our planet's history.
Absolutely.
But then, bam, we get the Cambrian Explosion. Talk about a party.
You could say that.
It's like life just went into overdrive, right?
Exactly.
Suddenly, we have all these new and complex creatures evolving.
It was an unprecedented burst of diversification.
And this is where we see the ancestors of most of the major animal groups alive today, isn't it?
That's right. The Cambrian Explosion really set the stage for the evolution of life as we know it.
It's like flipping to a whole new chapter in the story of Earth. And believe me, folks, this story gets even wilder from here.
It's amazing to think about, though, right? How life just comes back from these huge extinction events. I mean, it really shows you how resilient life is. You know, it can adapt and thrive even when faced with, like, total devastation.
Yeah, it's the ultimate comeback story for sure. And speaking of comebacks, that brings us to the Mesozoic era, otherwise known as the Age of Dinosaurs. I have to admit, dinosaurs always get me excited.
It's hard not to get excited about dinosaurs. They really capture your imagination, but a lot of people don't realize that the Age of Dinosaurs wasn't just this, like, big free-for-all. The Mesozoic era actually lasted for millions of years, and it's split into 3 different periods: the Triassic, Jurassic, and Cretaceous.
Oh, right. It's easy to think of it as just one big dinosaur party.
Yeah.
So let's start at the beginning with the Triassic period. This is where we see those first dinosaurs emerge. But this series made me realize something kind of funny about them.
What's that?
They weren't exactly giants, right? At least not at first.
You're right. Those early dinosaurs were surprisingly small. They were competing with other reptile groups for resources, and they had to be adaptable to survive.
So they were kind of like the underdogs of the Triassic, which makes their eventual rise even more impressive. So what was it that gave them an advantage over the competition?
Well, some of these early dinosaurs evolved grasping hands, which would have been super helpful for catching prey or gathering food. And some of them, like Coelophysis, were incredibly fast and agile. Oh, and here's an interesting tidbit. The ancestor of all dinosaurs probably had feathers.
Why feathers? I thought feathers were just for birds.
That's what most people think, but feathers probably had a bunch of different uses, like insulation or for attracting mates, long before they were used for flight. And actually, a specific group of dinosaurs called theropods eventually did evolve flight, which is how we got birds.
So that little robin singing outside my window is a dinosaur descendant. That's wild. But before we get ahead of ourselves, let's get back to the Triassic. How did this period come to an end?
Another mass extinction, although this one wasn't as bad as the Permian extinction, but it did wipe out a lot of the dinosaurs' competitors, which cleared the way for their rise to dominance in the Jurassic period.
Okay, so now we're in the Jurassic part. This is what most people think of when they hear dinosaurs, right? Giant sauropods, massive theropods, lush forests. It's like something straight out of Jurassic Park.
It really was a time of giants. We're talking sauropods like Brachiosaurus and Diplodocus, the biggest animals to ever walk the earth. These guys were so huge, they would have completely changed the environment just by moving around and eating.
It's amazing how small we are compared to those behemoths. And what about those carnivores? Did any of the famous ones live during this time?
Oh, definitely. Allosaurus was at the top of the food chain back then. It was similar in size and ferocity to Tyrannosaurus rex. And of course, we can't forget about Stegosaurus with its spiky tail and pleats.
The Jurassic sounds like a pretty rough place to be caught without a good hiding spot. It wasn't just about the land, though, right? What was happening in the oceans and the skies?
The Jurassic oceans were teeming with life, too. There were ammonites and belemnites swimming around, along with some incredible marine reptiles like ichthyosaurs and plesiosaurs. They had these streamlined bodies that were perfect for swimming. And up in the air, pterosaurs, the first vertebrates to evolve powered flight, were soaring around.
It's incredible to imagine all of these different ecosystems evolving side by side.
Yeah.
And that brings us to the Cretaceous period, the final chapter in the dinosaur story.
The Cretaceous saw dinosaurs continuing to rule. But we also start seeing some new faces, like the ceratopsians with their crazy horns and frills, and the hadrosaurs, also known as the duck-billed dinosaurs. Oh, and probably the most important development from this time, the appearance of flowering plants, or angiosperms.
Angiosperms, they sound familiar. Those are still around today.
So exactly. They're everywhere, and they completely changed the game for life on Earth.
So they're kind of a big deal.
Definitely. They took over the plant world and became the dominant type of plant on Earth.
So how did flowering plants shake things up so much?
Well, when they appeared in the Cretaceous, they revolutionized terrestrial ecosystems. They provided a new source of food for herbivores, and they co-evolved with insects, completely changing the landscape of life.
It's easy to forget about plants when you're thinking about evolution, but they really do play a huge role in shaping the world around us. But as we know, the reign of the dinosaurs and so many other incredible creatures came to an end with the Cretaceous-Paleogene extinction event.
That's right, the most famous extinction event of all. It was caused by an asteroid impact, and it marked the end of the dinosaur era. It really makes you think about how these random events can totally change the course of life on Earth.
It's kind of hard to wrap your head around something so catastrophic.
Right.
1 minute dinosaurs are ruling the planet, and then boom, they're gone. So what happened after this huge extinction event? What rose from the ashes of the dinosaur world?
Well, that's where the story gets even more interesting, because the extinction of the dinosaurs created an opportunity for a new group of animals to take over. Mammals. And that leads us to the Cenozoic era, the age of mammals, and the rise of a certain lineage of primates that would eventually become us.
It's wild to think this is where our own story really starts to unfold. After the dinosaurs exited the stage, Mammals really got their chance to shine, huh?
You could say that. The Cenozoic era, it's a long one, starting 66 million years ago and running right up to today. It really shows how adaptable mammals are, how diverse they became. I mean, we went from these tiny shrew-like creatures to, well, everything. Whales, bats, and, yeah, even us.
It's like evolution just took off running with so many possibilities. And the Cenozoic itself is split into these different epochs, right? Each one with its own quirks. So let's start with the Paleocene, right after that big asteroid impact. What did Earth look like back then?
Well, the Paleocene was all about recovery. Earth was healing, forests were spreading. Mammals were still pretty small, but they were evolving like crazy. But it wasn't just about bouncing back from the extinction. This is when some of the strangest mammals ever walked the Earth.
Okay. You've got to tell me more about these weird mammals. What kind of creatures are we talking about here?
Picture this. Inantotherium, a huge herbivore that looked kind of like a rhino, but with the 6 bony knobs on its head.
6 bony knobs? What?
Yeah! And then there was Coryphodon, another big herbivore, this one with a giant head and these ridiculous tusks.
These sound like something out of a sci-fi movie. What would even make them evolve like that?
It's a great question, and it shows that mammal evolution wasn't just a straight line from small and simple to big and complex. There were some weird detours along the way. Speaking of detours, in the Eocene epoch, Earth's climate went a little haywire with the Eocene thermal maximum.
Yeah, the Eocene thermal maximum, wasn't that a period of, like, crazy global warming?
You got it. Temperatures went way up, probably because of some massive release of greenhouse gases, though we're still not sure exactly what caused it.
So what happened? Did everything just melt?
Well, not quite, but it got hot. Really hot. The planet became a giant greenhouse with tropical forests stretching almost to the poles.
Tropical forests at the poles. Now that's just showing off. How did mammals deal with all that heat?
Some of them actually got smaller. Can you believe that? Smaller?
Yep. Smaller bodies meant they could lose heat more easily. We see this with early horses and even some of the first primates. It just goes to show that evolution isn't always about being bigger or stronger. Sometimes it's about being the right size at the right time.
That's a good point. And wasn't the Eocene also when the first whales showed up? That's a pretty big change, going from land to water.
Absolutely. The first whales, guys like Indoeus and Pakicetus, they still had legs and spent some time on land. But you can see they were starting to adapt to life in the water.
It's amazing to think they were the ancestors of the whales we see today.
Yeah.
And as if things weren't exciting enough, the Eocene gave way to the Oligocene, and Earth's climate did a complete 180, right?
It did it. The Oligocene was all about cooling down. The planet got chillier, and we see grasslands and more open habitats spreading across the globe. So goodbye, tropical beaches. Hello, grasslands. What kind of mammals did this climate favor?
This was great for grazing mammals, the ancestors of horses, rhinos, and deer. They thrived in these wide open spaces.
So while the whales were getting comfortable in the water, a whole new crew was taking over on land. And this is also when we see the first monkeys and apes starting to evolve, which means our own ancestors were starting to enter the picture.
Exactly. The Oligocene was a big deal for primate evolution. This is where we see the catarrhines emerging. They're the group that includes all the old world monkeys, apes, and of course us.
It's pretty amazing how these ancient climate shifts are woven into our own evolutionary history. And then we move into the Miocene. What happened then? More crazy mammals.
You bet. The Miocene was another time of big changes. A warm spell followed by a slow cool down that eventually led to the ice ages. Grasslands and savannas were spreading, and that's when we see the ancestors of elephants and giraffes appearing on the scene.
Those long necks and trunks. Those are some serious adaptations.
Yeah.
They must have given those animals a huge advantage.
Totally. Giraffes could reach those tasty leaves high up in the trees, and elephants, they use their trunks for everything. Grabbing things, communicating with each other, you name it.
It's like evolution gave them the perfect tools for the job. And then things start to get really chilly as we head into the Pliocene and Pleistocene epochs, the time of the ice ages.
Right, the ice ages. Glaciers, woolly mammoths, saber-toothed cats, giant sloths. It's like stepping into a prehistoric winter wonderland.
Minus the freezing temperatures, hopefully.
Yeah.
But seriously, the ice ages were a time of huge climate swings, with glaciers growing and shrinking all over the northern hemisphere.
Exactly, and they gave rise to some of the most iconic creatures to ever walk the Earth.
And it was during this time, right in the middle of all that ice and megafauna, that we finally see our own species, Homo sapiens, stepping onto the scene.
It's true. We were pretty late to the party showing up in Africa only about 300,000 years ago, but we wasted no time in making our mark.
That's an understatement if I've ever heard one.
We spread out across the globe developing tools and technology, and well, here we are today, the dominant force on planet Earth.
It's a lot to take in when you think about it. The sheer scale of Earth's history, from those first single-celled organisms to the incredible diversity of life we see today. It makes you realize that we're all connected to this incredible story, this grand unfolding narrative that's been going on for billions of years. And while we can't predict the future, I think understanding the past gives us a better sense of where we fit in and maybe even a little bit of responsibility for what happens next.
Well said. And it leaves us with a question. What new chapters will be written in the story of life on Earth? Only time will tell.